Hi everyone, myself Sheikh Roshan Zamir. I am from Computer Science of Engineering Department from E section. My topic is about graph of ultrametric type matrices. Now let's talk about the introduction of this topic. This presentation explores the intricacies of ultrametric type matrices and their application in graph structure analysis. We will delve into the fundamental concept and their significance in network theory. A graph of ultrametric type matrices is the graph that represents the connections and roots of a non-singular ultrametric matrix. An ultrametric matrix is a symmetric matrix that satisfies the strong triangle inequality, which means that the distance between any 2 points is less than or equal to the maximum of the distances to a third point. Ultrametric matrices can be seen as the potential matrices of Markov chains on finite state spaces, and their graphs can be used to study the properties of their chains. For example, the roots of an ultrametric are those points where there is a loss of mass in the Markov chain, and they can be found by using equilibrium potential. Now, let's talk about the second slide of this topic, ultrametric matrices. Understanding the concept of ultrametric matrices is crucial in discerning the hierarchical structure of graphs. We will analyze the properties and implications of ultrametricity in graph theory. A graph of ultrametric type matrices is a graph that represents the connections and roots of a non-singular ultrametric matrix. An ultrametric matrix is a symmetric matrix that satisfies the strong triangle inequality, which means that the distance between any 2 points is less than or equal to the maximum of the distances to a third point. Ultrametric matrices can be seen as the potential matrices of Markov chains on finite state spaces, and their graphs can be used to study the properties of these chains. For graph structure analysis, exploring the intricacies of graph structure provides valuable insights into the organization and relationships within networks. We will examine the methods for analyzing and interpreting complex graph structures. Algeometric matrices are special class of matrices that have a hierarchical structure and satisfy a strong form of the triangle inequality. They are related to ultrametric spaces, which are metric spaces where the distance between any 2 points is less than or equal to the maximum of the distances to the third point. Ultrametric matrices can be used to model phenomena that have a tree-like nature, such as phylogenetic trees. Hierarchical clustering. Hierarchical clustering techniques plays a pivotal role in uncovering the hierarchical nature of ultrametric type matrices. We will explore the application of hierarchical clustering in graph analysis. Matrix representation. The matrix representation of graphs offers a comprehensive view of their structural properties. We will examine the significance of ultrametric type matrices in capturing the relationships within the graph structures. Network theory applications. The principles of ultrametric type matrices have far reaching applications in network theory. We will explore their role in community detection, path analysis, and network visualization. Network theory is a branch of graph theory that studies the structure and properties of networks, which are collections of nodes and edges that represent some kind of connection or interaction. Network theory has applications in many disciplines such as physics, biology, computer science, engineering, psychology, and economics. Some examples of network theory are: in physics, network theory can be used to model complex systems such as particle collisions, phase transitions, and quantum entanglement. In biology, network theory can be used to analyze the structure and function of biological networks such as gene regularity networks. Complex network dynamics. The study of ultrametric type matrices enriches of our understanding of the dynamic behavior of complex networks. We will investigate the implications for network resilience and evolutionary dynamics. Structural equivalence. Unveiling the structural equivalence within graph structures is essential in understanding their topological properties. We will explore the role of ultrametric type matrices in identifying structural similarities. Communication detection. The detection of communities within graphs is a fundamental aspect of network analysis. We will examine the application of ultrametric type matrices in identifying cohesive substructures. Commu- Community detection is a process of finding groups of nodes in a network that are more connected or similar to each other than to the rest of the network. Community detection can help us understand the structure and function of complex systems, such as social networks, biological networks, communication networks, and more. There are different methods and algorithms for community detections. Depending on the type and size of the network, the definition and measure of community, and the desired outcome. Some of the common methods for community detection are divisive methods. These are these methods start within the whole network as a single community and then split it based on same criteria, such as edge edge betweenness, centrality, or conductance. Optimization methods. These methods try to find the optimal partition of the network that maximizes or minimizes some objective function, such as modularity, likelihood, or information. Generative methods. These methods try to fit a probabilistic model to a network data, such as a mixture model, a latent space model, or a stochastic block model. If you want to learn more about chemical detection, you can check path analysis. Analyzing path within graphs provides valuable insights into connectivity and information flow. We will explore the role of ultrametric type matrices in path analysis and shortest path algorithms. In conclusion, the exploration of ultrametric type matrices has illuminated the intricate nature of graph matrices, illuminated the intricate nature of graph structures and their significance in network theory. The insights gained have broad implications for diverse fields. The for giving this opportunity. Very, very thank you.